Hi, everyone, and welcome to our next lightning talk. I'm Samantha Kim, and I'm part of the marketing team here at solo.io. I'm excited to introduce our next lightning talk speaker. Please help me welcome Marino back to the stage to talk about business continuity with Gloo Mesh. Marino, over to you.
Thank you very much, Samantha. Hey, everyone, again. Welcome to my talk on business continuity with Gloo Mesh. My name is Marino Wijay. I am a developer advocate at Solo. So I'm here to talk to you about how we can achieve things like disaster avoidance and even aid your disaster recovery processes and business continuity with service mesh technologies. But first, let's talk about outages for a second, or for a few minutes, if at all. When running a company, our business functions may either support things like our internal workforce for a variety of tools that they might consume, or we might be using business functions that actually support our streams for revenue. These business functions actually or generally map to applications either that we built organically in-house, or they live outside in an as-a-service world, or they're consumed as a service. But for a few minutes, let's understand what can contribute to an outage. So outages can actually be caused by a variety of factors, both technical and non-technical in nature. Some can be internalized, some can be externalized. It doesn't matter. At the end of the day, an outage is an outage, and that could be a small part of your environment. That could be the entire thing, but it contributes to an outage. DNS, for example, if not available, can cause substantial outages, as we are so reliant on things like name resolution. So if we're trying to communicate using IPs and we don't have our name resolution in place, things tend to break. DNS servers, what we tend to do with them is deploy them in a high availability state. So that way we have one, if it goes down, we have another one that's available to just continue to process those name resolution requests. In the case of storage, that system holds all the data that we consume in a company, all the data that we store, that we generate. It's stored in some sort of repository, or it can be spread. But it's storage. We're talking about storage arrays, storage networks, and even disks. So we have the possibility of running out of storage. We run out of capacity. And when we do run out of capacity, guess what? We have nowhere to write to. So the system comes to a halt. I/O itself becomes halted, or input-output becomes halted. And it's like a storage network or a storage environment in itself can have a lot of different kinds of failures. So we also want to consider how that can contribute and radiate to the other parts of our environment. Sometimes the network is the source of a potential outage. Network equipment can age, it can fail, network cables can fail, transceivers for fiber optics can fail. Someone can cut a fiber and then your network has failed. There could be potentially some level of oversaturation to and from a particular environment, and that is actually causing huge spikes in latency, and furthermore contributes to a level of inaccessibility or a lack of availability. Consider for a moment like a misconfiguration. Single misconfiguration for, let's say, BGP or other routing protocols can be catastrophic to a network environment, because those routing changes can propagate elsewhere and then cause unavailability issues as well. And then we have to think about security for a second, because someone or some automated system might have accidentally pushed a policy that automatically denies all services from one location or with a certain set of attributes from communicating with another set of apps with another set of attributes. And that in itself will lead to a break in communication. And then this moves us on to the concept of availability, which, when you think about it, really motivates us to consider constructing things like service level indicators, service level objectives, and even service level agreements to just ensure that we're always maintaining a level of availability and resiliency for our business and for the applications that run inside them. And then finally, the last part is people. Like, how do we ensure that we are enabling our workforce, our people, to recover from these failures, and that they have the right systems, the right tools, the right technology to solve a lot of these failover problems. So what technology can I think of, or can anyone think of, that can actually solve a lot of these challenges? Service mesh. All right, so let's dig into service mesh and what we're doing here. So up in this diagram, I have a single Kubernetes cluster, which can be running anywhere. It can be running on EKS. It can be running something that you built on premise, or something that you built in another cloud. It doesn't really matter, but it's upstream Kubernetes. And then we've got Istio service mesh running as well. Now, this grants us a lot of capabilities in itself. If we take a look at this simple approach right here, we effectively need to make sure that DNS resolves to our desired endpoint, which could be either the Kubernetes API endpoint for running kubectl commands, or the Istio CTL command that we want to run against Istio to see what's going on in our network. Additionally, we might be also accessing applications within that Kubernetes cluster. So we'll be making HTTP requests through a load balancer or through DNS. But behind DNS, we actually have a load balancer. And this load balancer is actually responsible for handling all those incoming requests to either manage a Kubernetes cluster's control plane, because in a Kubernetes cluster, you're going to want a multi-node control plane environment in addition to a multi-worker node environment. But this load balancer is there to protect that control plane. If you lose a node inside of Kubernetes, or if you lose a control plane node inside of Kubernetes, you still have a control plane that is functioning, that is actually allowed to pass instructions down to the worker nodes to allow you to schedule pods and run containers, and even still do that level of networking. It allows you to still traffic shift or move around your services as needed. But this is a function of a Kubernetes cluster itself, wherever you've deployed it. Kubernetes that's in itself actually gives us the ability to heal, let's say if a pod fails, or even gives us the ability to scale and create a number of replicas or copies of a pod. And this is primarily built off of the belief that at any given time, a Kubernetes pod can just disappear, can die off. But we need to use a declarative approach to recreate that object. And once it's been recreated, then it's there for us to continue the same function as it did previously before that pod died. Now, beyond what Kubernetes provides us from high availability standpoint, the underlying Kubernetes cluster might be managed or monitored by a service provider. Now, that service provider, or cloud provider for that matter, is responsible for making sure that cluster is up and operational. So if for whatever reason you lost a node in your cluster, the cloud provider's automation will go in there and reinstantiate another node to bring your cluster back to its original state. Now, this is all great and well. And then, we have recovery for our applications, and we have ways to route to multiple parts of our application within a cluster. But what about MultiCluster? Now, in the case of MultiCluster recovery and failover, any single service or endpoint can fail. An entire cluster or an environment can fail. You might even have cross-cluster traffic going on. How do we actually achieve some cross-cluster resiliency in the event of a failure of, let's say, a service, or even maybe a node in a cluster, or even the entire cluster itself? Since we've distributed our application, parts of it might end up in different Kubernetes clusters. So how do we go about routing to all of these different locations? So we could leverage, let's say, a service mesh and Istio's specific objects like virtual services and destination rules, and even service entries to just create the necessary policies to get around to where we need to go. But having to do this for so many services at scale is impossible. So what do we do now? How about a CI/CD system? A CI/CD system might be able to solve part of that problem for us, but not entirely, because it doesn't have it doesn't have the complete awareness of all objects in all locations. And then this is what brings us to something like Gloo Mesh. So I'll talk about Gloo Mesh in a second. But what if we can further abstract, let's say, the Istio service mesh and treat all of our Kubernetes clusters as if they were all part of the same network fabric? We actually can, and we do so with Gloo Mesh. So with Gloo Mesh, we can leverage something called a route table resource that basically tells us where all of our services exist, whether service A is in cluster 1, or service B is in cluster 2, or all the copies of service B are across all clusters, the route table is going to tell us that. And so this route table is actually a direct translation of Istio's resources, specifically those virtual services, destination rules, and even service entries. But we're simplifying that configuration because now all you need to do is configure your route table resource to configure where things are, much like a routing table in the networking world. You configure your route table to say, here's where this network is, where that network is. This is the same idea. So this is actually allowing us to effectively traffic engineer where our requests to our applications go and even specify alternative paths. So if there is a failure, let's say cluster 1 goes down or cluster 2 goes down, and cluster 1 needs to access something in cluster 2, but it's non-existent anymore, cluster 1 can route to cluster 3 without a problem. And this is all made possible using Gloo Mesh and its management plane to provide the management and abstractions on top of Istio Service Mesh. So with this capability, we can achieve great resiliency in the way our applications respond. We can achieve higher levels of availability, and we even simplify our configurations. Gloo Mesh itself works by understanding the configurations you pass it, like the route table. And then in turn, like I mentioned before, converts that or translates that into Istio resources. The other thing that I need to mention is that Gloo Mesh actually unifies the root CA amongst all of your Istio instances. So now all of your different environments here, all of your different clusters are sharing that same root certificate or root CA certificate that enables them to trust all services amongst each other. This is actually a very huge simplification in configuring service mesh while giving us the resiliency, the continuity, and any sort of oversimplification of how we configure our resources all within our Kubernetes clusters running Istio and now Gloo Mesh. So to wrap up, business continuity is a very broad topic. I mean, I covered a lot of different areas where things can go wrong, but most of the time, a lot of that comes down to the network and several other things around capacity planning and your available storage and even the systems, the foundational systems, for example, like your clusters and where they run. What we aim to solve here is with our Gloo Mesh technology, we can provide you a way to continue your business and its functions, provided that you have some sort of outage or a small portion of your environment goes down. While Istio provides a very powerful service mesh that gives us things like traffic management and other capabilities to basically allow us to connect our endpoints and services together, it also allows us to circumvent failures locally. And if we take that to the next step and we leverage Gloo Mesh, we can streamline and simplify our configurations while also circumventing failures across all different locations and sites. So to simplify, Gloo Mesh is your answer to augmenting your business continuity and disaster avoidance and recovery strategy. I hope you enjoyed this lightning talk. Thank you, and please enjoy the rest of SoloCon.